is JA Solar. The next speaker on our agenda is Tao Wang. Tao is product manager with JA Solar and has been working in solar for over a decade. His job at JA Solar primarily centers around the development of high efficiency solar modules, pre and post sales, and technical support work. Tao will talk to us about the advantages of 182 millimeter cell-based modules in manufacturing. Welcome, Tao.
Welcome. Thank you.
Yours.
Yeah, thank you, Michael. Can you hear me?
Yes.
Okay. So I think it's a little late. So let's just start. Okay.
You look still fresh, so.
Yes, thank you. So wait a moment. Okay. Can you see the PPT now?
Yeah, works. Thanks so much.
Okay. So let's start. So today, everyone, I'll give you the brief introductions of J182 products, manufacturing advantages and analysis. So there are three aspects of my topic today. First is the introduction of 182 products design background. And second is the introduction of 182 products manufacturing situations, current situations. And last is the future outlooks. So let's start the first part. So first is the introduction of 182 products background. So here is the historical trends and outlook of photovoltaic LCOE trend. So we see in the last decades, we see a tremendous cost reductions. And also by the ARENA forecast and for the LCOE and to 2030, so the PV costs will drop below 3 US cents per kilowatt. And recently we see, I think everyone sees the technology innovations like increased module powers, equipment cost reductions, and production and management cost optimization, for material cost optimizations, and production process optimization. And recent years, the wafer size influence, I think, is the main part. So we see next slide. We see here. We see the recent years. We see the wafer size goes from G2 to M6, and now M10. Currently, plus MBB half cell technology is the module power and 72 layouts can go to 545 watts. And here I give you some aspects why we can think 182 products is where it comes from. Yes, we consider the current limitation of module size. For example, like Liu just told, for the containers and module layout adaptations for the current like glass equipment, and the cell and module technology upgrades based on current equipment and technologies, and the limitation of the module current for better performance and reliability, and also the integrated cost per watt considerations. Here we compare with M6. We see the best cost reductions of the LCOE advantages of the 182 products. So next slide is the introduction of current J182 products manufacturing situations. First is let's see the crystal pouring process. The crystal pouring rate of 182, and then the crystal formation rate. We compare 158 and M6 ingot growing ratio and the whole ingot qualified ratio here. So we see between them they are basically the same, and the yield per unit are also similar at present. Also we see there is still room for 182 growth in the subsequent year per unit. And second, we see the wafer slicing process. Currently yield of 182 in slicing process is slightly lower, and the wire diameter is slightly wider, but we can estimate soon they will reach the same level with the current G2 products. As here show you the details. Currently the higher yield of G2 about 100 higher than 182 wafers, and the diamond cutting diameters a little cost a little higher for 182, and but the slicing yield per unit currently is basically the same. And the third part is the cell production process. So first, for the large wafers, we will consider some risks here. So I list here below. So first is the online and controls like sheet resistance and PECVD process uniformities, and some cleaning effects. And also some yield risks like contact contaminations problem or poor printings, and also for the big size wafers, we needed to consider reliability risks like mechanical load, PID. Here we show you the yield of 182 cells. Currently is basically the same with M6 wafers. After the process production, currently is stabilized in J, and also the efficiency also is expected to be the same soon. And you see here the qualified rate nearly the same. And also the key important is cell reverse leakage, and the distribution data is the key for the reliability of the modules. Currently, we collect 9 days output data for the reverse leakage, and we see here the range from 0 to 0.5 amps is more than 99%. Also, for the at the cell side for the 182 platforms, we also have many technologies to further improve the module efficiencies. We estimate up to 23.1 efficiency can get through process optimizations, like below, from the SE optimizations, heat resistance optimizations, and backside preservations, and some light capture optimization, and paste and metallization optimizations. Here for the module power achievement, we list here is August 2022 first J182 cell S30 series modules. We see the power output distribution here. The module efficiency highest reach the module power highest reach 545 watts, and module efficiency can up to 21%. And also we see here our 182 products maximum usage of the container space here. Here we list the sites, and we also compared with G1 and M6 size products. We see 182 products shipped in the container can smoothly for the transportation, and have about 10 to 20% more watts per container than old G1, G2, and M6 products. And also here we see the equipment maturity now from the crystal pouring, slicing equipment, module equipment manufacturers, and cell process equipment manufacturers. We see here 182 platform, mainly equipment suppliers also diverse, with typically 2 to 4 qualified suppliers for each process listed here. Let's take some cell and the module key equipment, for example. So here we see the from the current J mass production data, we see excellent equipment performance. For example, for the cell diffusion, PVCVD printing, and module side soldering and laminations, and the output capacities, crack rates, and some like stabilities, all is very good. And last, also we check the supply security is also important. We check the supply chain from the silicon wafer to key form materials. Here we see first is the capacity of the crystal pourings in 2021. We see many capacities for the 182, nearly 2 250 gigawatts. And for the glass suppliers, also half capacity can make matched with the 182 glass productions, and also some encapsulations like PUE and also the EVA. We see mainly capacities can secure our shipments next year. And last, we some future outlooks. Here we think the key three aspects for the continuous LCOE reductions in the future. So here is we see we based on the platform of 182 platforms and from the silicon wafer technologies at the cell technology. So we can combine with low oxygen content and better wafer resistivity and lower material impurity technology at the wafer side. And also for the cell side, we can combine SE, MBB, high heat resistance and dense grid technologies and better passivation and advanced light captures and the paste and metallization process. Also, at the module side, we can combine with high density technologies like shingle, paving, and other technologies. And for the layout designs is also flexible for the 182 platforms. We can do like 54 cells designs for the rooftop and 66 and 78 for the flexible design of the utilities. And also on these platforms combined with N-type technologies like HJT and TOPCon to get the module power more than 600 watts. And last is the continuous product performance improvements and cost reductions and higher quality POM material suppliers and challenges here. And also, I think these three backs are the key for the LCOE reductions. So first is the higher power and higher reliability can secure continued performance improvement, and cost reductions we based on higher production capacities, higher yield, and BOM material supplies. We need to check the high quality silicon wafers, high quality BOM materials, and the solutions we see we needed to based on the increasing investment in product technologies to continuously improve the product powers and reliability, and also secure the supply through the strategic partnerships with BOM material suppliers. And also we need to make the best use of the advantages of integrations to improve the quality and the supply of products at all process. And last aspect, strengthening the lean manufacturing management to improve production capacities and yield and reduce manufacturing costs. Okay, That's all my introduction. Thanks. Thanks for listening.
Thanks, Tao, for this insights on your strategy going 182. There are a couple of questions, and we have a few minutes left. So, what's the average cell efficiency of the 550 watt product? Could you reveal that you're producing now?
Okay, you mean the PPT?
No, in general, what is your cell efficiency for 540 watt products around? So what's your the per cell efficiency you are using for your 540 watt plus modules? What's the average?
You mean the current cell efficiency? Currently,
yeah, cell.
Currently is average about 22.9.
Okay. And so there's also one question regarding cells. So are you using gallium dope wafers at JA or
Yes, and from at JA we call it deep blue. Deep blue 3.0 products, and all these 182 wafers JA use gallium doped technologies.
Okay, perfect.
Yeah.
What else do we have? Maybe you can talk a little bit also about the packaging for 182 and what kind of advantages you see there. So packaging and transport in containers. I think there are a couple of questions regarding that.
Yes. So let's maybe not give you very clearly. So let's also why the 182 size comes from. Yeah, we count the two. You see the two pallets up and downs. So and the current the height is the maximum usage of the container space now. With this traditional packaging method, and as I know, only leaves about 10 centimeters handling space for the container now. Yes.
Okay. So how many
maximum usage of the space?
How many modules fit in a box and then in a container?
Currently is one pallet is, as I remember, is 31, and total is 20 pallets in one container. That's
okay.
620 numbers.
Okay, perfect. Okay. What else do we have? Do you can you say there's a follow-up question on gallium doping? So which share of gallium or the deep blue will you have basically this year, or what's your roadmap for? Will all modules at some point be gallium doped?
Yes. Yeah, for example, maybe for our older products like G1 and G2, not all use gallium doped, but for our deep blue 2.0 and 3.0, that's M6 and M10, all use deep blue, gallium doped wafers. We see the very good LED performance and LED performance for those technologies, and J also is first patent buy from the patent holders from the Japanese manufacturers. So they give those higher performance products to our customers and also give the benefits to our customers.
Okay. I think there was one question: is there a relation between LETID and wafer size?
I think don't have the relations. LETID, I think mainly based on the the wafer qualities. I think how to say the reasons, the root cause is currently is the impurities in the wafers, and then some cell manufacturing process like hydrogen functions. So not have the relation with wafer size, as for the wafer quality and a cell treatment process is the key influence.
Okay.
Okay. Yes.
Also, with the larger modules, how do you see larger modules and glass reduction actually? So, so what's the thickness of the glass when modules are becoming bigger that you are using?
Yes, that's a good question. Good question, actually. So yes, we need, from my opinion, we need all the industry all need to pay more attention to the qualities when the panel size growing bigger and bigger. But we need to control the module weight, especially for bifacial double glass modules. So all the glass thickness currently use 2.0 millimeter thickness. So all the industry need to pay attention to the uniformity of the glass surface strength, then secure the module mechanical load performance for example, at the transport and at last the plant operations. For the wind load, snow load, yes.
Okay. Are you having 180 millimeter, 182 millimeter products also already for the residential sector, or is it mostly for ground mount systems?
Sorry.
The panels you are using?
Sorry, bad connections.
Okay, so the one question is actually about how actually your 182 millimeter products work also for the residential segment in comparison to the ground mount segment.
Yes, last design, residentials we currently consider now for the for our customers, and for example, maybe in the future, when the G2 size phase out in the market, so we needed to at the 182 platforms, we needed and develop more products for the diverse applications. For example, some rooftop and utility. Sorry, commercial rooftops.
Okay, perfect. Then Tao, I think time is over. Thanks so much for your contribution, and I wish you a nice rest of the evening. Thanks for joining us so late.
Okay, thank you.